In today's video, I'll show you how to spend much less time writing R code. We'll go through a typical data analysis in 5 different ways, and at every step of the way, I'll show you how to make your code shorter. That way you'll learn to spend less time typing R code and will get to your results much quicker. So with that said, let's dive in. Now, in order to do anything, we first need data. So let's take a look at the classical Ames housing data set. This has a lot of information on houses in Ames, Iowa. And the easiest way to get the data is via the model data package. And now if you take a look at this data set, you'll realize that it has a whole bunch of columns. In level 1, we want to take a look at the columns that are related to the sizes of different parts of the house. These columns are indicated by the SF abbreviation in their column name. And with these columns, we want to run a little analysis for every neighborhood in the data set. So let's first throw in all the necessary columns into the select function, and we'll do this by the super slow and super boring way of copy and pasting all the different column names into select. Maybe you want to have neighborhood, maybe you want to have this basement fin SF1, maybe the same for SF2, and this is rather tedious. You have to go through all of these things one by one and find them and stick them in there, but after you've done all of that, you have a smaller data set, so hooray, at least we've accomplished something. In the next step, we might want to convert the square feet numbers to square meter numbers, because let's face it, the imperial system isn't great and the metric system is much better. And I know, shots fired, but let's just go with it. Let's pass our data to mutate. In level 1, you might take all of these columns one by one and then transform them using the adjustment factor, which when you want to transform square feet to square meters, you will have to divide the number by this magic number here. And then you might copy and paste this here some more, very tedious. And then you just take the variables from above until you are done, which isn't fun to do at all. And it is really error prone. I hope I get through this without making a mistake, and then you realize you don't even have enough rows here, so you throw in some more. So all of these should now be translated to square meters. So now if we re-execute this, we see now that we have different numbers here. Finally, we might want to get all the mean area sizes for every neighborhood, so we'll pass our data to the summarize function. But this time, even while we're still in level 1, I'll show you a cool little trick that you can use in RStudio to make the process a little bit faster. So let's check that out. So we throw this to the summarize function, and then we stick all of these columns into the mean function. And instead of copy and pasting here, let me show you a little trick that you can do in RStudio. Let's just throw this in here, and then if you press the Alt button and drag your cursor down, you see that you have multiple cursors. And now you can use these multiple cursors to write something like mean something something, and then you just have to stick in the column names in here. It isn't that much better, but at least you don't have to do a whole lot of typing. Also, I really wanted to show you this cool trick because I think multiple cursor is kind of a cool thing. And then finally, we want to have this by neighborhood. And now if we execute this, we see that we have the mean square meters for different parts of a house by neighborhood. Ooh, this was a lot of work. Let's try to see if we can do better with level 2. In level 2, we can get rid of the long list of variables in the select function. Instead, we'll just use tidy select helpers. They are a really underrated tool to make your code much nicer. If you take a look at the documentation of this package, you'll realize that it doesn't even have a hex sticker. This goes to show that the tidy select helpers might not be as appreciated as other packages, but they are still very helpful because you can just translate this long list into a short command that says use all the columns that contain this SF here. So let's just stick this into contains SF, and then we don't even need multiple rows. We can just stick all of this into a short little select command. And now if we re-execute this, we see that we get the exact same result, but it was much smoother to work with the tidy select helper here. Sweet, that worked pretty smoothly. And in level 3, we can now do even better and remove lots of duplicate code. You know, because duplicate code is never fun to write and it takes a lot of time, even if you use this cool multi-cursor feature. And this is where the across function comes in. You can stick it into the summarize call and in there specify the columns that you want to iterate over and the function that you want to apply. Here we want to apply the mean function, and the columns that we want to apply this on are really these columns here. So all we have to do is to stick in a vector with these names, and then we can get rid of this part here and rerun this code. And once again, we see that we get the same result, but we have much conciser code and we have less duplicate code. In level 4, we can do the exact same thing, but for the mutate call here. This time we don't use a built-in function, but just divide the column by some number, but that's no problem, we can do the exact same thing as in here. Let's just copy this part here and stick it into mutate, because across also works in mutate. And then instead of applying the mean function, we can define our own function using the shorthand notation. And in this shorthand notation, we can specify argument names. Let's just call the argument name square feet. And then we say our function is just defined by square feet divided by this number here. And then we can get rid of all of this here. So now what we have done in mutate is to iterate over all of these columns here and apply this custom function on all of these. Once again, if we execute this runs perfectly, same results, but much less typing. Of course, you can use this technique here when you want to use a function that already exists. For example, you could use the mean function and stick in the square feet in there, and then also specify that you want to use the argument NA_remove and set it to true, and then you get rid of the other stuff. And that way, once again, same results, but you can also use this shorthand notation to use function that already exists, but with specific arguments. Finally, in level 5, we can do even better. We can use this tidy select helper also inside of a cross. So instead of having this long vector of column names, we can also stick in a tidy select helper there. And then all of a sudden, our code becomes so short that it even fits onto screen. So now if we execute this, again, we see the same result, but the code is so much nicer. It's much easier and faster to write code like this. And finally, let me throw in a bonus level for you, something that I do on every data analysis, which seems mundane, but it does speed up things because you then don't have to worry about column names. Namely, I stick in the data set into the janitor clean names function. And if you execute only this function, you see that we then have also all the other columns, but you see here that everything is transformed into snake case. So if you have a data set that has white spaces or special characters inside of the column names, then janitor clean names will clean all of that up and make a nicer programming friendly naming out of that. And then you can use these nicer names in your programming. So then if you use in select, you don't have to use these backticks to write special characters like white spaces. So that's pretty nice. But one thing you do have to be careful then is that you have to adjust your code a little bit. Obviously, usually you start with these clean names and then you don't have to adjust your code here, but we started the other way around, so we have to do that. And now since we're looking for capital SF, we won't find that. So instead, let's look for lower SF. But since this might also match other things, let's also throw in the underscore in front of that. And now we almost get the same result, but here we also have to modify the variable name. And now everything looks as it did before, but it has more programming friendly column names. So that's how you can turn a tedious calculation involving lots of columns into short and concise code. If you enjoyed this video, I'm very certain that you're also going to enjoy my data cleaning masterclass, which is a course with lots and lots of goodies like this that help you with all kinds of data cleaning tasks, like working with time data, working with character data, or some other general productivity tools. If you're curious, you can follow the link that pops up right now, or if you want to see some of my other free videos, you can check them out via this playlist here. And with all of that said, I say thank you for watching and I will see you next time.